Gravity and Creation by L.S. Larkey, the trilogy available on Amazon today. Distinguished colleagues, honored guests, and seekers of cosmic truth. It is my profound privilege to stand before you today and unveil the Grand Febernachy Unified Theory of Gravity, a sweeping new vision that redefines our understanding of the forces sculpting galaxies, stars, black holes, and the entire expanding universe. Over the decades, we have grown adept at spotting cracks in the standard frameworks, from dark matter mysteries and dark energy enigmas to the perplexities of black hole singularities. Yet each time we've tried to fix these cracks, we often ended up with separate patchwork solutions, exotic components or fine-tuned expansions, never fully shaking off the sense that something more elegant might lie waiting. This speech aims to walk you through the logic and the luminous promise of a single unified paradigm, one that might truly unify cosmic gravitation without recourse to invisible halos, ephemeral fluids, or infinite meltdown points. We gather here under the luminous achievements of Newton, Einstein, and the many giants who taught us the laws of celestial motion. Yet across the last century, as our telescopes brought galaxies and cosmic epochs into sharp focus, we found ourselves forced to add dark matter to explain galaxy rotation, dark energy to address cosmic acceleration, and we've had to accept singularities with infinite curvature that defy the known laws of physics. Each invocation has felt uncomfortably ad hoc, like conjuring invisible players that only appear to fix local contradictions but never reveal their fundamental nature. Grand Febernachy steps forward with a single principle, that gravitational pull is less fundamental than we thought. Instead, the cosmos is governed by a push-based synergy linking subtle magnetic fields, higher dimensional fields that intensify under the right rotational or fractal conditions, and relative vacuum of space, a dynamic fractal vacuum whose pressure changes in tandem with these fields. In simpler language, we have a cosmic vacuum that is not empty, but is alive with fractal self-similarity, creating gentle or powerful pushes that can replace what we once called gravitational pulls or negative pressure fluids. From the smallest star to the largest cosmic web, a single fractal Fibonacci scaling ensures consistency across all scales. This approach can replicate and transcend the successes of general relativity, while eschewing the need for invisible matter, intangible energies, or meltdown singularities. One long-standing puzzle is why galaxies rotate with nearly flat velocity curves. In classical Newton-Einstein logic, if only luminous matter is present, outer stars should orbit more slowly. Observational data, however, reveals a near constant speed out to large radii, implying a huge halo of dark matter to keep them from flying away. For decades, we have sought these dark matter particles, WIMPs, axions, sterile neutrinos, without conclusive evidence. Grand Febernachy redefines the rotation dynamic. The outward push from the subtle fields and the fractal vacuum is mild but consistent at galactic distances. Instead of diminishing with radius, these push-based forces scale in such a way that star velocities remain constant. No massive halos needed, no extra free parameters to guess. One field synergy does the job. Indeed, feeding real rotation curve data into the Fibonacci model yields the same shape we historically attributed to hidden halos. Thus, galaxies spin gracefully in a fractal vacuum, free of ephemeral lumps of dark matter. Another cornerstone problem is the accelerated expansion discovered through Type Ia supernova measurements, typically accounted for by dark energy or a cosmological constant. If one tries to interpret as vacuum energy, quantum field theory overshoots the observed scale by factors up to 10 to the power of 120, the so-called vacuum catastrophe. Meanwhile, we measure dark energy as about 70% of the cosmic energy budget. Yet we can't detect it in the lab or fix its value to standard quantum fields. In the Grand Febernachy approach, there is no separate fluid called dark energy. Instead, the fractal vacuum synergy drives a gentle cosmic push that becomes relevant at large scales. This push modifies the cosmic expansion equations so that, after matter density dilutes sufficiently, the push emerges as an effective acceleration. Observationally, we get the same data fits as before, but with fewer conceptual leaps. The coincidence problem, that dark energy becomes dominant right now, vanishes when expansions are governed by fractal vacuum laws rather than an unchanging cosmological constant. By adjusting exponents in how SMF and RVS scale with cosmic size, we get just the right mild cosmic push for the observed acceleration. No cosmic fine-tuning, no mysterious negative pressure fluid, a single continuum bridging local star orbits and the entire Hubble flow. Standard general relativity demands that once mass collapses behind an event horizon, it can keep collapsing to infinite density at the center, a singular meltdown where curvature goes infinite. This is widely acknowledged as a breakdown of classical theory, typically requiring a quantum gravity fix. But after decades of research, we still don't know how singularities are truly avoided. Under Grand Febernachy, meltdown singularities never form because as matter tries to compress, the vacuum synergy intensifies, saturating at extremely high conditions. That saturation exerts a powerful push from within, capping the density at some finite maximum. You can still get an apparent horizon for external observers, but no absolute meltdown to a point. The result is a black hole that in practice looks just like a Schwarzschild or Kerr hole to an outside observer, matching gravitational wave ring-downs and event horizon telescope images, yet inside it is stable with finite densities. The dreaded infinite meltdown is replaced by a fractal vacuum equilibrium. In effect, we unify black hole structure with the same synergy that explains galaxy rotation and cosmic expansions, elegantly wiping out the singular meltdown problem. Supernova explosions. Instead of a catastrophic meltdown that tries to bounce via neutrinos, spin-driven dispersal under fractal expansions can blow off the star's outer layers more directly. No stalling shock fiasco. The leftover is a stable neutron star, again push-supported. In this narrative, we skip many complexities, focusing on how rotation plus fractal synergy yields a robust outflow consistent with observed supernova energetics and remnants. Baryon asymmetry. Our universe has more matter than antimatter, a puzzle usually explained by ad hoc CP-violating processes. In the Fibonacci approach, repeated small expansions in the early universe or vacuum bursts can tip matter-antimatter production slightly, culminating in net matter dominance. No separate seesaw or heavy new boson required. The vacuum synergy can break equilibrium just enough to build the baryon fraction we observe. Our process. The formation of heavy elements like gold or platinum needs rapid neutron capture in extreme astrophysical sites. Mergers of push-based neutron stars or spin-driven supernova outflows can produce more robust, neutron-rich ejection, allowing these metals to be formed in sufficient quantity. Thus, the cosmic distribution of precious metals emerges from the same fractal synergy that prevents meltdown or accounts for cosmic expansions. Primordial magnetism. The same synergy that shapes the vacuum from the earliest times can yield strong cosmic magnetism. No specialized magnetogenesis scenario is needed. From the Big Bang onward, a fractal cosmic environment fosters large-scale seed fields that later get amplified in galaxies and clusters. Fast radio bursts. For FRBs, the synergy can produce abrupt vacuum snaps in high-field star or magnetar environments, unleashing millisecond radio pulses. The repeating versus non-repeating categories might simply reflect how many snaps or reconfigurations occur. Here again, the push-based synergy emerges as an overarching solution to short lifetime cosmic phenomena that require enormous energies in tiny volumes. Where standard astrophysics often has to juggle multiple invisible or intangible entities, dark matter, dark energy, meltdown singularities, Grand Febernachy merges them all under the unified notion of vacuum push. This synergy is fractal in nature, meaning 1. Across small to large scales. The same set of laws shapes planetary orbits, star spins, galaxy structures, cosmic expansions, black hole interiors, and more. 2. No contrived add-ons. Because you never needed to invent a separate fluid for each puzzle. Everything flows from one principle, letting the fractal expansion solve multiple riddles simultaneously. This is reminiscent of how we once replaced separate electric and magnetic fluids with Maxwell's single electromagnetic theory, or how general relativity replaced gravitational force with geometry. Now, the next leap is to see gravity itself as part of a cosmic push-based synergy. The vacuum is not inert, but fractally alive. In the Grand Febernachy Unified Theory of Gravity stands as a sweeping reinterpretation of the cosmic tapestry. Having solved or addressed galaxy rotation, cosmic acceleration, black hole meltdown, supernova outflows, baryon asymmetry, R-process enrichment, primordial magnetism, and more, it points us to a future where we systematically verify push-based synergy with data from the next wave of cosmic surveys and telescopes. Just as Maxwell's unification supplanted separate electric and magnetic fluids, or Einstein's geometry replaced Newton's forces, Grand Febernachy now attempts to replace the dark placeholders and meltdown singularities with a fractal vacuum synergy. If observations keep confirming these vacuum expansions, we might soon be writing the final epitaph for dark matter, dark energy, and meltdown singularities, welcoming the cosmos into a new era of clarity, one grand synergy weaving across all scales, from the spin of pulsars to the swirl of galaxies, from cosmic dawn to the black hole horizon. That is the bold promise of the trilogy Gravity and Creation by L.S. Larky, a push-based gravitational revolution, bridging the largest cosmic riddles and the subtlest vacuum quirks in a single luminous tapestry.